In this lecture, we are going to look into the remaining scanning techniques that's left for us and hopefully implement them into our Python script in this lecture. So the first one that we are going to look in this lecture is the null scan. So a null scan, we have the client sending a packet with a no flag, just as the name suggests, null. So with no zero flag, with no flag whatsoever. It's like a TCP packet with no flag over a particular port that it wishes to communicate with the server, and then if it doesn't receive any response from the server, then we can say that that particular port is open. And then, however, if the response is a packet that contains a reset flag, then we can say that that particular port is closed. So basically, that is how null scan functions. And then, however, if the response is an ICMP error type 3 code 1, 2, 3, 9, 10, or 13, then we can say the port is filtered. Then the next type of scan is the TCP acknowledgement scan, ACK scan. Now, what happens is that the client will now send a packet with a TCP plug, with the TCP with the ACK flag, that is with the ACK flag over a particular port. Now, if the response is a packet that has a reset flag, then we can say the port is unfiltered. So basically, ACK scan is not used to check the state of a port, whether port is open or closed. ACK scan is used to check for the presence of a firewall. So when we receive a reset, a packet with a reset flag, then we can say that there is the absence of a firewall. You can say the port is unfiltered, so there is no any firewall blocking our scan. And then, however, if the response happens to be an ICMP error type 3 code 1, 2, 3, 9, 10, or 13, then we can see that the port is filtered, so there is a stateful firewall blocking our scan. Alright, now the next type of scan is the window scan. Now in the window scan, basically what happens is that if the client wishes to communicate with a server, we now send a packet with an ACK flag over a particular port. Now, if it receives a packet as a response with a positive window size, then we can say that particular port is open. However, if the response happens to be a packet with a reset flag and with a 0 window size, then we say the port is closed. Now, another type of scan is the UDP scan. Now, in UDP scan, basically, UDP is the opposite of TCP because we transmission control protocol and user datagram protocol. Now, in transmission control protocol is called reliable connection, connection-oriented communication. However, UDP is connectionless oriented communication. So here what happened is that the client will send a UDP packet over a particular port. Now, if it receives a UDP packet as a response, then we can say that the particular port is open. However, if the response happens to be an ICMP error type 3 code 3, then that port is closed. However, if the response happens to be an ICMP error type 3 code 1, 2, 9, 10, or 13, then the port is filtered. There is a firewall blocking our scan. Now, however, if we send a UDP packet over a particular port and there is not any response, then either the port is open or filtered. Here we have the algorithms of the null scan, the ACK scan, the window scan, UDP scan, and now we try to translate this into Python code and include it in our port scanner tool. So we are going to go and start with the null scan. So I'll just go over there and then define a new function and then call it null scan. So I'll just come down here and then define a function, then call it null. Then this will require a parameter, a target as one of the parameter, and then port as one of the other parameter, just as we did before. So I will just go over there and then copy the code that is here in the pin scan and then make the necessary amendment to turn it into a null scan. Alright, so I'll just copy it and then copy and then come down there on the null scan and then paste it. So I will just come here and paste it, and then I'll go through, look at the algorithm and then try to modify it into a null scan. Alright, so So we have all the scans contains up to line 152 is common among the scans. We are basically creating a scan packet and then sending this scan packet, but only that in null scan, as we said, we are sending a TCP packet with no plug. That is why it's called null. So I'm going to do away with this, and then we are going to send a packet with no plug. So we are going to leave the value as an empty, as a white space, as an empty string. All right, so we send it, and then let's go back to the algorithm and then see. So what response are we expecting? If no response, then we can say the port is open. Okay, and then if we have a response with an RST packet, then the port is closed. So we are going to check a packet with an ACK and RST packet with an acknowledgement and reset packet. If we have that, then we can see that the port is closed. The port is closed. Yes, we can see that the port is closed. So we are checking for code number. We go back to our table. RST and ACK has the decimal value equivalent of 20. So if we have a TCP plug of 20, equivalent numerical equivalent of 20, then we can see that the port is closed. So we come here and check scan response. Here we are checking for TCP dot plugs equivalent of 20. Then once we have it, so it's closed. So we are not going to make any changes here. So we go back to the algorithm again, and then if the response with ICMP error type 3 code 1, 2, 3, 9, 10 or 13, then we can see the port is filtered. So likewise here also, it is the same thing here. In scan response KP ICMP type 3, and in as also KP.ICMP code in 1, 2, 3, 9, 10 or 13, though we can see that the port is filtered. So basically it has a lot of similarity with the previous pin scan that we did, only that here we are not sending any flag, we are leaving it empty, null. All right, so and then else, if no response, then we can see that the port is open. So it is either it is open since it is no response, so either it is open or filtered, because we can't confidently say it is open because we didn't get a response. All right, so it is either it is open or it is filtered. So with this, we have successfully implemented the null scan, and now we can invoke it and run it, quickly run it, and then if there is any error, then we try to correct the error. So I'll just come here and then do away with this pin, and then null scan, then go over the terminal and then try to scan Windows 10 machine with it. So I'm in the directory where I have this Python script. So I'll just try to then. So it's not SMS. We are not doing SMS. We are doing a null scan about port 80. And then I'll hit enter. So enter my password. Okay, so we are having that the port is closed. So basically what we had here, the port is closed, null scan, the port is closed. So that means that the error, the TCP.plug we have is it has an R reset flag within it. So that is why we can come to the conclusion that that particular port is closed. So now next, we are going to implement the next type of scan. Now the next type of scan is the acknowledgement scan, the ACK scan. And as we said earlier, this scan is not used to check whether a port is open or closed. We are only basically using it to check whether there is the presence or absence of a stateful firewall. All right, so we are going to send a packet with an acknowledgement plug. So just come here and then define a function, define a new function, and then call it ACK scan. So I'll just come down here a little and then define a new function, and then I'm going to call it okay, just two lines is okay. Then I'm going to call it ACK scan. Scan. All right, so just then come down, and then we have and then we are going to pass two parameters, our target that we are going to perform the scan on, and then the port that we are going to scan. All right, so and then I'll just go over here there again and then copy it. So I think I still have it in my clip bin, so I'll just paste it. So we make the necessary amendment and then modify it into the into ACK scan. All right, so here we go back to the algorithm. We are sending a packet with an acknowledgement plug, with an acknowledgement flag. All right, so we just go over here and then make sure that the flag is a acknowledgement flag, All right, so we save it. So after specifying the flag as A, which stands for acknowledgement flag, then we send the packet. So we go back to the algorithm again and then try to make sure that we're on the right track. So we send a packet, we send the packet to acknowledgement flag. Now if we receive a packet response with an reset flag in it, then we can say the port is unfiltered. All right, so the port is unfiltered. So we have the response here. If it's not equals to none, that means we actually have a response, and then tcp.flag, and then it is a flag. It is a packet with a reset flag with it. So 20 stand for reset and acknowledgement flag as according to our table here. So now we can see that the port is unfiltered. So it is not closed here. Here we are going to change it from closed to unfiltered. So we can conclude that it is unfiltered. Okay, so the other condition is that we go back to our algorithm. Now if we receive a response instead with an ICMP error type 3 code 1232910 or 13, then we can see that the port is filtered. So we go back and then check. So we say we have the same code. We are not going to change anything here again as well. So if we have this as the condition, then if this condition in line number 175 is evaluated true, then we can see that the port is filtered, just as we have according to our scan algorithm. So we go back and then we only have two conditions, either it is filtered or unfiltered. So I'm going to do away with this. I'm going to do away with this. If we have response, so if we have a response, if we have response, because it cannot give us the state of the port, whether it is open or closed. So we are only going to have two issues, either it is filtered or unfiltered. All right, so I'm going to save it now and then go back and run this script and then see whether if we have any error, then we fix the error. All right, so we are not invoking null scan, we are invoking scan. So I'll save it and then go to the terminal and then run it and then see if there's any error, then we fix the error. Right, so we are not performing null scan, rather we are carrying out an scan. So I'll just okay, so we run it. Okay, so we have an error here, so we need to go and see what the error is. Okay, line number 175, we have in scan code in res index error, layer not found, layer name. Right, option the target port, acknowledgement scan. Okay, so we have a layer ICMP not found, index error, res layer not found. Now to actually understand the nature of this error, let's print out the let's invoke method summary on the packet, and then let's see what the a summary about the packet, information about the packet, and then see how we can handle this error. So I'll go back to the code again, and then before returning the whatsoever value that you want to return, either filtered or unfiltered, let's print out summary.packet.summary. On the packet is scan response, as we know, scan response packet. Then let's invoke method summary on it, summary, and then likewise here as well, let's print it out. If it is the other response, let's copy this one, and then before we return here, let's print it out and then see what the error is, and then let's see how we can be able to handle the error. So I'll save it, I'll go to the terminal, and then you will run it and see. So I'll run it and see. Okay, enter my password. Okay, so here we are having some none again. We are having none as the error, as our output, none. All right, so that means there isn't any response. So perhaps the firewall is blocking our there's a firewall that is not even allowing any response. So let's go back to the Windows machine and then see. Okay, so we can see that the firewall is enabled. So the firewall is enabled. So we can add this functionality that to our code, that if we get none as a response, it's an indication that a firewall is enabled on the machine that we are trying to perform the ACK scan on. So I'll go back to the code and then add that functionality. Okay, so let me go back to where I'm calling the code to make sure. So actually we invoke ACK scan, so we are on the right track. So let's add for a functionality. So if we didn't get a response, so else, that means we didn't get a response, because at if line 171 we are checking if we actually scans response actually has a value. So but since we enable our firewall and then we invoke the ACK scan, we run the ACK scan, and we can see that the response was none because our firewall is enabled. So now let's handle that issue by showing that if our response is none, then that means that the firewall is enabled. So we return filtered. So we just return filtered. So we just return filtered. So that means there is a firewall that's not allowing any response. All right. So we have this. All right. So let's go back and run the again, and then see whether this has actually handled our case. So let's run it and see what the issue is going to, what the output is going to be. All right, perfect. So as we can see, it's actually filtered. All right, it's filtered. So and we know that a firewall is enabled on the Windows 10 machine. So now let's disable it and then see what the output is going to be. So we disable the firewall, and then let's go back and run the code, our script again, and then see what the error is, whether we are going to have an error, and if we have an error, then we see how we are going to also handle that error. All right, so we still have this error, layer ICMP not found, right? So we are going to see how we are going to handle this error also as well. All right, so now next we are going to implement the ACK scan. So and we have the algorithm here already. So just go over there and then define a new function. So I'll just come here and then define ACK scan. So I'll call it ACK scan. All right, so and then put the parentheses, and then give this one down a little. So and then so I'll also go over there, copy the codes from our previous scan, and then make the necessary modification according to the ACK scan algorithm. So I'll just copy this, copy it, copy, and then come and paste it under the ACK scan function that we have just defined. All right, so up to line number 168, everything is similar, with the exception that line 166, under the flags, since we are going to carry out ACK scan, so we are going to send a TCP packet with the ACK flag set. So we are going to set A here to specify an ACK flag. All right, so we go back to the algorithm and then try to modify line 170 to 177 to suit our ACK scan algorithm. So when we come back here, we say we are going to send a packet with the acknowledgement flag. We have already done that. Then secondly, we are going to, if we get response with a RST packet, the reset packet, then we are going to conclude that the port is unfiltered. So we come here and then check for a packet with the reset flag. And then as we have defined 20 is a decimal equivalent for a combination of the reset and the acknowledgement flag. So we are also in, everything is in order here as well. And then when we have that, go back to our algorithm, then we are going to conclude that the port is unfiltered. All right, so we go back here, instead of having it closed, so we are going to return unfiltered. So I'll just write unfiltered, and then I'm going to save it this. filtered. All right, so and then I'll go back again and then check. So the next step is we are going to check if the response has this ICMP error type 3 code 1239110 or 13, then we say the port is filtered. Also, this also corresponds to what we have here in line 174. We can see we are checking for if it has layer ICMP and the field type, it has the value of 3, and int, also the field code in layer skp.icmp is having one of these values, either 1, 2, 3, 9, 10 or 13, then we can going to return that that particular port is filtered. So basically that is the only condition that two conditions that we are going to have. Either it is open, either it is unfiltered or filtered. Also, if we didn't receive a packet, we are going to return that it is filtered, not open here, because we are not arc flag will not tell us whether a port, the state of the port, either a port is closed or open. It can only tell us whether a port is filtered or unfiltered. So if we didn't get any response, we can also conclude that that particular port is filtered. All right, so I'm going to save it this, and then we go and run this script. So we just go and make sure we invoke it. So we go down and call that particular function. Okay, so we change here from null to scan, and then we invoke the scan and then see whether we are able to perform the scan. All right, so I'll just here I'm on the directory, so I'm just going sudo. All right, so let me just make use of the arrow key to access the last command I ran. Okay, so we have acknowledgement flag. Okay, acknowledge is already set as acknowledge type of scan port 80. So I'll just run it and then see. Okay, my password. All right, so we have okay position I were given. All right, so we didn't specify any. All right. While defining the function, we didn't specify parameter, so we are going to pass actually target and port that we are going to perform the scan on. All right, so I'll save it. We'll go back to the terminal and then rerun it again. So we hit enter. So we're having an error. Okay, index error layer ICMP not found. Okay, so we don't know about this error. I don't know about this error, but raise index error layer not found. Okay, so let's see how we are going to handle this error. Let's try to print out the layer ICMP not found, index error layer ICMP not found. So this error happened in the line where we are checking for the ICMP type of packet. Okay, ICMP packet, and then it just returned the error, index error layer ICMP not found. So let's go and try to see how look into and see how we are going to handle this error. So we go back to the code and then see. So this error happened in the line where we are checking the whether that particular packet has this layer. All right, so what we are going to do, if scan response equals to none, let's make use of what we call exception handling technique. Let's make use of try. Now try is a technique for handling error, and then what we call exception handling. So we are going to use it to handle that error and then print out the packet, so that we will know, we will learn more about this error. We will see what causes this error and then try to rectify it in our program. So I'm saying try, and then I'm going to push this under the try block. Return unfiltered. Okay, so and then also elif scan return filtered. Okay, and then all right, so basically I'm saying try to run the code under this under your block. So I'm telling the Python interpreter to try to run the code under this try statement. If scan response has layer skp.tcp, and then it's going to check whether there is a flag with the reset and acknowledgement flag set in it, and then if that happened, it's going to return unfiltered. And then because we know that an error is going to occur here in line number 175. Okay, so now I'm going to handle that error by adding another statement except, and then I'll go to that my terminal and then get the name of that error. The name of the error is index error, so I'll copy it and then go back here and then I'm telling to right. Wow. Okay, so I let me undo. I wasn't unable to copy it. Undo paste. I just copied I pasted the code that I was having on the clip bin. So let me go back and get the go to the terminal, copy this arrow, right click, copy, make sure it was the index arrow that I copied. So index, and then I'm going to paste it here. All right, perfect. So now I'm telling it to there's an arrow called index arrow is going to occur. So if that index arrow occur, then I want it to do something for me, and that's something I want it to print the packet so that I will know what causes the error. So print scan response dot summary, so that we will see what actually causes the error. All right, so print scan response dot summary. All right, and then we are going to see what actually causes this particular error. So I'll save it, and then I'm going to go to the terminal again, and then run this script, and then see what the issue is. Okay, so we have our scan response. We have our packet. It is coming from our target 10.0.2.15, which is the Windows machine, over for HTTP port 80, where we actually send the scan, and then it is coming to our machine over this port 50536, and it is having a reset flag in it. So it is sending a reset flag in it. It's having a reset flag on it. So let's go back to our code and see. So we are checking, but we are actually checking for reset flag, and we expected to have a reset flag. According to our algorithm here, we are expecting to have a response with a reset packet if the firewall is enabled, so that we can print out if the firewall is disabled, so that we can print that the port is unfiltered. So we're not able to print out that. So what causes the issue? Because here we are checking for a combination of the reset and the acknowledgement plug, because actually that packet, the packet only have reset flag. It doesn't have an ICMP layer. So that is why we are having that error, that ICMP layer was not found. So we have index error, layer ICMP not found. So just basically a simple packet with a reset flag in it, and we're supposed to, and what skip it here, the issue here, we instead of checking for only reset flag, we are checking for reset and acknowledgement plug. So actually, and then if we go back to, let's go back to the Windows machine and see if the firewall enabled or disabled. Okay, it state it off, so the firewall is disabled. So actually that is why we are having a packet with a reset flag. So we just come and make a modification here. Instead of checking for a reset and acknowledgement flag, we are only going to check for a reset flag. So I will delete this 20 and then go back and then check what is the numerical equivalent of a reset flag. That is either 4 in decimal or OX 4 in hexadecimal. So I'm going to make use of the decimal because it's more it's convenient. So I'm going to check for 4, and if this evaluated true, then I'm going to actually print out that the response is unfiltered. That means there is no a firewall at the target that I'm trying to scan. So let me save it now and then see if it is okay. We are able to get the right response. Then we are good to go, right? So and then let's go down. Okay, we are printing the response. Okay, so let's go down. Let's run the script again and then see what we are. Let me clear the terminal so that we'll be able to see clearly what we are going to have as the output. Perfect, we have it unfiltered. So actually we are wrongly checking for reset and acknowledgement flag instead of only checking for. So in our case, if we are checking whether a port is filtered or unfiltered using ACScan, we are only going to check for the presence of a reset flag, not reset and acknowledgement flag. All right, so not reset and acknowledgement flag. So then return unfiltered. So we can now our something is okay, and then let's go back and disable the firewall and see whether what we are going to have as response. So I'm going to disable it. Okay, enable it rather. So I'm going to enable it now since we have unfiltered, so that we can have the response as filtered. All right, so now we are going to enable the firewall at the Windows target machine. Okay, so now we have enabled the firewall at the Windows target machine. So let's go back now to the Kali attacking machine and then run the script and then see whether we are going to have the right output. So run it, filtered, perfect. So we can see our script is working according to how we expect it to function. If there is a firewall, print filtered. If there's no firewall, print unfiltered. All right, so but basically here we printed the scan.response just for us to help us understand the why we have that error, and we have understood the error and we have handled the error. So let me delete this except index error and then print. So next time I don't think we are going to have this index error anymore. So but let's see except. All right, so there's something. All right, so we have else. We are checking for if scan response is not equals to none. That means we actually have a response. And then else, if there is no response, if the response is none, there's no response, then we return filtered. And then index error, we are not doing anything except index error. So we can do away with the try since it has served its purpose. We're not expecting any error again anymore. So let's do away with that else. So I'm going to also do away with this, and then we are going to run the code to make sure that everything is okay before we can move to the next function, right? So I'll move this one up here again, if scan a response, and then we are going to return, and then also the elif here, we are going to move it, so elif. And then we are checking for if the layer escaping the at ICMP layer exists, and then we are checking for the field type and if it has the value 3. So also, and then if that if all that condition evaluated true, then we are going to return filtered. All right, so let's go and run this script. If everything is okay, then we can move to the next function. So I'll move to the script. Go to the terminal, then run it, and then see what we are going to have on the output. Okay, filtered, perfect. Okay, so let's go and disable the firewall, and then try to go back and run the script again, and then see what we are going to have. All right, so it has been disabled, so let's go back and run it and then see if it is okay. Perfect, we're having unfiltered because the firewall is disabled. So now our scan has been successfully implemented, and now we can move over to the next type of port scanning technique. All right, so now let's see how we can implement the Windows scan. And this is the algorithm of the Windows scan that has been provided. So we are actually going to send a packet with the acknowledgement flag, and if we receive a response with an RST packet with a positive window size, then we can say the port is open. However, if we receive a response with an reset packet with 0 window size, then the port is closed. And if we have no response, then the port is actually filtered. All right, so now let's go to the code and then decide and implement this window scan. All right, so here I'll just come down here. I'm going to define a function and then call it window scan. Window scan. All right, and as usual, we are going to define our 2 parameters. We are going to, whenever we invoke this function, we are going to pass target and port. All right, so I would still go up here and then copy this code, copy the code under the scan, and then paste it under the new Windows scan that we just created, and then make the necessary modification to have a window to perform window scanning. So we'll be going back to the algorithm and then make the necessary modification to this window scan. So let's go back. We are going to send a packet with an acknowledgement flag. So out here we are sending a packet acknowledgement flag, and then next we go to the algorithm again, and then if we have a response with an RST packet with positive window size, okay, so we are checking for a packet with a reset flag and a positive window size. So basically what we are testing, we are checking for a flag, this window size. This window is another field that is within the layer SCPI TCP, and we can actually print this out. So after scan response, let's print this packet and then try to see this particular layer so that we can know how. So let me just comment this one out. I'm going to scan response dot show. All right, dot show, and then let's see that particular layer and then see how we can implement this accordingly. So let me put colon here, let me put triple quote and then comment this one out. I'll go down here. I'm not commenting the whole of the code, just this particular segment, and then I'm going to disable this. So now we are printing this particular packet, scan response.show, and then we are going to see the various layers, fields within this particular packet, and then see the how we can that particular window that I was referring to, the window that was referring in the algorithm here, if it has a positive window size. So let's okay, so we need to go and the line of code that invoke the function. So we are going to change it from scan, which was the last scan that we implemented, and then change it. Let's just invoke window scan. All right, so I'll go back again to the terminal, and then okay, so I'm not in the folder, so let me navigate to the directory where I have the that particular file, which is in desktop lectures. So here I'm moving two directories backward into the desktop. I'm in desktop directory now, so I move to lectures, and then I'm in the proper directory here. I can clear the terminal, and then I'm going to run the script, enter sudo python 3, and then I'm going to name of the script, name of the file is portscanner.py, and then I'm going to enter the target 10.0.2.15, and then I'm performing window scan, and then over port 80, so I'll just hit enter my password, and then let's see, because we basically here we're just printing out that particular packet using method show to see the layers and the fields of that particular scan response packet, so that we can see the window, okay, the window field. So this is the window field that we are referring to. So we are going to check for the value in this particular window field. Okay, so we have seen it is under the TCP layer. All right, perfect. So now let's go back and then try to implement this window scan scanning technique. So let me do away with this. We have achieved what we are trying to achieve. So disable it so that our code will now be enabled. Right, so do away with this. So now we are checking for if the scan response actually has a value. If it has a value, then we are checking for SCPI TCP layer as we have been doing before, and then now we are checking the key. So everything we refer to the algorithm. So send a packet. So if a response packet with a positive window size, then we say port is open. If response with a reset packet with a positive window size. So we are also checking for reset flag. So reset flag, if it has a reset flag, and we know that 4 is the value for reset flag. If it has reset flag and a positive window size, so we have to check for another criteria again, that is a positive response with a reset packet with positive window size. Okay, so we can just add the other condition here and say and if scan response kp tcp.flags. So with kp response dot window, I will just copy up to here, and then I'll just come and paste it here. So we are checking for that layer, and that layer we are checking for the field called window, just as we have it on the terminal here. So we are checking for the window. Now we have checked for the flags if it has R. So now we are checking for the window, whether it has a window field. What is the value of the window field? All right. So and then if these two conditions evaluated true, then we are going to take the necessary action. So window. So let's go to the algorithm. We are checking if it is a response with the RST packet and with positive window size. So positive basically means something greater than 0. So a positive number is a number that is greater than 0. So we are checking if this particular value. So let's convert it to int so that we won't have any issue, even if it come as a string or as any data type that is not an integer. So we won't have any issue. So convert it to int, and then now we are going to check if it is greater than 0. Then if it is greater than 0, then we want this particular action to take place. So what is the action? We go back. We are going to return that the port is open, which is step number 3. So we return that the port is open. So we just simply return here and say that the port is open. So I'll just come here and write return open. All right, perfect. So and then you go back to the algorithm again. Then if it is a response with a set packet but with 0 window size, then the port is closed. So the same thing here, but only we are checking if it is a negative number. So if scan, so I'll just copy this up to here, just copy it, and then we go back. We're not checking for an ICMP, so we are checking for window size. It is a window scan. So I'll just come and paste this here, replace it with this. But we are checking for if it is with 0 window size. It has the packet with 0 window size. So we are checking if it is equivalent to 0. So if the field, the value of the window field is something that is equivalent to 0, then we want to return. So we go back and see what we are supposed to return. We are going to return that the port is closed. So we simply return that the port is closed. So I'll just come over here and write closed. All right, closed. All right. Okay, so I'm not supposed to select. So call it save, then go back again. Now, if we didn't receive any response, then that means that particular port is filtered. So we can, if else, return filtered. Perfect. So we have this. So we are going to go and invoke. Okay, we have already invoked it in this main body of the program. So we are going to go to the terminal and run it, and then if we have any issue, any error, then we come back and correct the error. All right, so let me clear the terminal now, and then run the code, and then see what we are going to have as output. Okay, so we are having an error here. We have a leaf, and then we have if. So we have some syntax error there. So let's go and correct the error. Line number 192. So line number 192. So we just go down here 192. So we have to do away with this if, and then we save. Then we go back and then we run it again. And this is what we are going to have as our output. Closed. Okay, perfect. So we can see that our function, window scan, is working correctly. But let's go back and analyze. Did we get the right response? So we can see that it's closed. So if we have in scan response and the Windows field is greater than is equivalent to 0, then we can see that that particular port is closed. So now let's locate an open. Okay, let's try to get a port that is open so that we can have an open as our response. Okay, so I'll just come here. I will make use of a map to actually perform scan on that particular machine, get the port that are open, and then we make use of our port scanner, also using the Windows scan, and then scan and see whether we can going to have we are going to have open as the response. So 10.0.2.15, and then I hit enter my password. All right, perfect. So we can see these are the four that are open. 135 is open, 139 is open. So let's scan for 135 using our on-foot scanner. So I'll just come to this side of the terminal, and then I'll scan for 135, then hit enter. Closed. Okay, so we are having it closed, but we implement. So let's scan for another port again, port 139 or port 445. So let's scan for port 445 and see what we are going to have as our response. Port 445, hit enter. We are still having it as closed. All right, so let's go back and see our code and see whether we have scripted everything correctly. So we are checking for if it has reset flag, and we are checking if the window size is equivalent to 0. Then if it is equivalent to 0, then we are going to return close. And is that what we're having on the algorithm? Yes, you set reset packet with 0 window size, then we can say the port is closed. Okay, and then if there's no response, port is filtered. Okay, but let's check if the port is filtered. Let's enable the firewall, and then we say, okay, let's go to the Windows 10 and enable the firewall, and then see whether we are going to have filtered as our response. So I will enable the firewall, and then okay, so now we are going to enable the firewall and then see what the response is going to be using our Windows scan. So I'll go back to the terminal and then run the script again, and then see what our response is going to be. So if we get filtered as a response, so we are sure that we are on the right track. So perfect, we have it as filtered because and actually we have the firewall enabled, and we were able to get the response as filtered. Okay, so our Windows scan has been implemented correctly. So now next we are going to move over to the UDP scan, which is the final scan type that we are going to look in this lecture. Okay, the lecture is getting lengthy, so we are going to stop here, and then in the next lecture we are going to look at the UDP scan, and then hopefully conclude this port scanner section.